Hello everyone. In this video we are going to have a look at how we can do something that is called simplifying square roots. And although there is only one specific learning goal for this topic, we are actually kind of discussing two things. Namely, how to write a square root as a single root and how to simplify square roots. So it's quite a lot that we're covering here. You might want to watch the two parts separately. I'm going to start by writing as a single root how we do that. Then we do some examples, then we look at why we would want to do that. And then we go have a look at simplifying square roots. First, I'll mention what that even means. Then I'll go through two different methods, explain the methods and look at some examples, and then explain why we want to do that. Either one of these methods work perfectly fine. So if you prefer one method over the other, that's perfectly fine and you can ignore the other. Anyways, let's get started. So suppose we want to write something as one square root. What I mean by that is maybe you have 7 square root 5 and you want to have everything in the square root. How do we go about that? Well, what we are going to do is we are going to start by, first of all, writing this 7, in this case, as a square root. Well, how do I write a number as a square root? Well, 7 is the square root of 49 because 7 squared is 49. So that means I can write 7 square root 5 as square root 49 times 5, square root 5. But then we've already seen before how we can multiply square roots. So at this point I can just multiply them together and get square root 245, and now it is written as one square root. So let's do a few more examples. Let's have a look at 3 square root 6 and then also at 8 square root 2. So 3 square root 6, I start by writing the 3 as a square root. So I get square root 9 times square root 6. And then I do the multiplication. 9 times 6 is 54. The second one, if you want to try it yourself, you can pause the video. Otherwise, I'm going to explain how this one works. So this time we write the 8 as a square root. 8 squared is 64, so 8 is the square root of 64 times square root 2. And then we do 64 times 2, which is 128. So that is how we write something as one square root. But why would we want to do that? Well, suppose you want to know which one is larger, 2 square root 3 or 3 square root 2. Now, usually the solution is going to just be fill it into your calculator and see what it gives. But without a calculator, we can't really compare them. But let's see what happens if we write them as one square root. So 2 square root 3 is the square root of 4 times the square root of 3, so the square root of 12. 3 square root 2, well, 3 squared is 9, so this is the square root of 9, times the square root of 2, so this is square root 18. And now we can compare them because clearly square root 18 is larger, so actually 3 square root 2 is larger than 2 square root 3. So that is a reason why you would want to write something as one square root. As it turns out, actually, what we're going to be using more often is to simplify square roots. But what is that? Well, in the previous slides, we wrote something as one square root. So we went from 7 square root 5 to square root 49 times square root 5 to square root 245. Simplifying a square root goes exactly the other way around. So we try to have this square root as small as possible. So we're simplifying, we might actually start with square root 245 and we try to split it up as square root 49 times 5 and then get to 7 square root 5. Somehow this square root is not finished. Oh well. But that seems quite complicated. How do we go about this? So as I said, I've got two methods for that. So let's start with the first method, perfect squares. So let's say we've got square root 72 and our goal is to write it as some x times square root y, and y has to be as small as possible. The square root has to be as small as possible. And we're going to use perfect squares for that. So the squares of whole numbers, 4, 9, 16, etc. What we're going to do in this example of square root 72 is we're going to find the largest possible perfect square that we can divide 72 by. So if we go through the list, clearly we can't divide it by 100, nor by 81, nor by 64 or 49, but we can divide 72 by 36. So we're going to use that to write square root 72 as a multiplication. Square root 72 is the square root of 36 times 2. And now, from this point, we can kind of do the opposite of the multiplication rule to split this up into square root 36 times square root 2. Again, be careful, this only works with times. It doesn't work with plus or minus. But now that we've got this, we've got to the point of why we need perfect squares, because this square root 36 is exactly 6. So we can just write this as 6 square root 2. If we would have split it up in any other multiplication, then maybe we couldn't have simplified it like that. So that's why we need the perfect squares. And as a final check, can we divide 2 any further? No, we can't, so this is simplified as far as it goes. Let's try this with a few more examples. So what you can do if you want to is you can pause the video and try them for yourself. Otherwise, I'm just going to explain them. So square root 1800. Well, it's kind of already in the word 100, so we can divide in this case by 100 and get the square root of 100 times 18. And then we can split it up as square root 100 times square root 18. And well, square root 100, that's just 10. So this is 10 square root 18. Can I divide 18 by any more of these? Actually, I can. So I can continue this process because I can still divide square root 18 by 9. So let's continue to the right here. 10 square root 18 is actually also 10 square root 9 times 2. So that's 10 square root 9 times square root 2. Oops, with the square root. And square root 9 is 3. So that's 10 times 3 times square root 2. And our final step, 10 times 3 is 30, so 30 square root 2. So I've already picked quite a difficult example here because one step was not enough. But this way, by taking those two steps, first splitting it up with 118, and then double checking and noticing we can do more, split it up in 9 and 2, we get the simplified version. So I'm sorry by immediately giving you this difficult example. 150 is going to be a more easy one. Because what can we divide by? Well, we can't divide by 100, nor by 81, 64, 49, 36, nope. But we can divide by 25. So this is actually square root 25 times 6, or square root 25 times square root 6, which then gives us that this is 5 square root 6. Can we divide 6 any further? No, we can't. So this one is done in just one application of this rule. For the record, I'm fine with it if you skip this line, so also this line, in your calculations and go straight to square root 25 times square root 6 to show your notation. So this is the one method. This is the method that uses perfect squares. Let's get to the second method, the method of factorizing. And we're going to start with the same example, that same example of square root 72. But this time what we're going to do is we're going to split up 72 into its smallest factors. We're going to make it as large a multiplication as possible. So what I'm going to do is I take 72 and I split it up. 72 is, well, we already saw in the last one, it's 36 times 2, so that's a nice one. I can't split up 2 any further, so that's fine. 36, I might write it as 9 times 4. But 9 is 3 times 3, and 4 is 2 times 2. And then I can't split up any further. Of course, I can add ones, but I can just add infinitely many ones, so we're not going to do that. So square root 72 is square root 2 times 2 times 2 times 3 times 3. Now the next step is to take every double factor out of the bracket. So we've got double 2's, double 3's, and then we just have this 2 left. So I'm going to take a 2 out and I'm going to take a 3 out. Every double becomes 1. And then we just simplify that, multiply, so we get 2 times 3 is 6 square root 2, which is the same answer we had before. This is a bit more of a magical method where we don't really look at why it works, but if it's stupid and it works, it ain't stupid. So we just use this method, it works, it gives us the answer. So let's try a few more examples of this. Let's try square root 48 and square root 405. Now, one thing to note here is you don't necessarily have to split it up to the smallest factors. Once you find a double, you can already take it out. But it's just that if you go to the smallest factors, you can be sure that you have found all the doubles. All right, anyways, let's start with 48. So 48 seems like 4 times 12 to me. 12 times 4. 4 I can still split into 2 times 2. Hey, I've already got a double there. And 12, well, that's 3 times 4. And then 3 I can't split any further. 4 is 2 times 2. So I can write this all the way as that, if I want to, as 3 times 2 times 2 times 2 times 2. And then I take out the doubles, so that's these. If I would have been smarter, I could have just used the 4 and the 4 here already, but it doesn't matter. So I've got the 2's and the 2's, so I've got 2 times 2, square root 3, so 4 square root 3. If you want to check if you use the method from before with the perfect squares, it gives the exact same answer. Square root 405 then, let's also split up 405. Seems like a large number, seems difficult, but I already see this 5, so I can clearly split it up into something with 5. Hey, that's 81. 81 times 5. And 81, I remember that as being 9 times 9. And that's nice, because I can split 9 further, but I already have a double here, so I'm not going to worry about that. So this is 9 times 9 times 5. If you split it further into 3 times 3 times 3 times 3 times 5, it gives the same answer, so that is perfectly fine. But for now, I save myself some time by finding, hey, 9 times 9, I split the 9 out, I take the 9 out, and the 5 just stays in the square root. So this is the second method. It is the method of factorizing, just finding the doubles. In this case, for notation, I'm fine with it if you skip this one, but then I want to see how you factorized it still. So I want to see some sort of factorization. All right, that's all fine, but it seems like a lot of work. Why would I want to do this? So suppose you have to calculate square root 32 plus square root 50. Well, then we've seen in an earlier video, they are different square roots. We can't add them. Or can we? Let's simplify these. So for square root 32, I'm going to use the first method. For square root 50, I'm going to use the second method. So square root 32, the highest perfect square I can divide it by is 16. So this is square root 16 times 2. 16 is 4, so square root 16 is 4, so this is 4 square root 2. Then 50. 50 is, well, seems like 25 times 2, and 25 is 5 times 5. Cool, we have a double here. So I can take the double out to get 5 square root 2. Which means that actually square root 32 plus square root 50 is 4 square root 2 plus 5 square root 2, which can totally be added and gives us 9 square root 2. So in this case, simplifying means that we can actually add them together. More generally, we always simplify our square roots to keep them smaller, and that makes them more manageable. It's kind of like simplifying your fractions. Fractions should also always be simplified. Similarly, square roots always have to be simplified. So it's just kind of a convention so that we always write square roots in the same way. So keep that in mind and make sure that you practice simplifying your square roots. So that was a lot of talking, a lot of examples, but I hope this helps you figure out one method that works for you to simplify square roots. And now it's time to put those methods into practice.